Hello students, so today I will discuss center of mass. Okay, this is the second part of our chapter, that is system of particles and rotational motion. Now center of mass means what? First of all, you see this is not a mass. Okay, center of mass is a position, it is a location, it may lie inside or outside the body or a system. Now center of mass means what? It is a point where the entire mass of the body is supposed to concentrate. That point is called center of mass. That position is called what? Center of mass. Okay. Suppose for example, you consider a sphere. So for a sphere, the geometrical center is the position of what? Center of mass. So here the entire mass of the body is supposed to concentrate. If we consider a square or rectangle, then the intersections of the diagonals, so this is the position of what? Center of mass. So here the entire mass of the sphere, that is square, is supposed to concentrate. That position is called what? Center of mass. So in case of your regular shape bodies, that is a square, a rectangle, or a sphere, a triangle, the geometrical center is the position of what? Center of mass. If we consider triangle, in that case, the intersections of the medians, okay, means the centroid. So this centroid is the center of mass. Okay. So what is center of mass? It is simply, you can say that it is the point. It is the point where the entire mass of the body can supposed to be concentrated. Supposed to be concentrated. So this point is called what? Center of mass. Okay. Now here, what is the importance of center of mass? At the center of mass, the body is balances. Okay. That means you can consider a situation. Suppose this is a body. Suppose the body is moving under some external forces. For example, you are applying here 2 Newton force, and this suppose 3 Newton force. And suppose the body is moving with a velocity of, so for example, 5 meter per second. Now here, for example, this is the position of center of mass. Now if we apply the resultant force, the net force directly applied at the center of mass, okay, then the motion of the body remain unchanged. That means here you see, this is the position of center of mass. Now you apply the resultant force, that is 5 Newton, in the line of center of mass. Okay, here, this is the center of mass. We apply force, that is 5 Newton here, 5 Newton. In that case, its velocity remains same, that is 5 meter per second. So, this is the concept of center of mass. That means the motion of a body remain unchanged under some external forces if the resultant of the force is directly applied at the center of mass. Okay, because here the entire mass of the body is supposed to concentrate. That means it behaves as like the total body. So here you can say, you can make a point that the motion of a body remain unchanged. Okay, remain unchanged if unchanged under some external forces. Under some external forces, if the resultant of all the forces is directly applied directly applied at the center of mass. Okay, at the center of mass. So this is the concept of what? Center of mass. First of all, what is center of mass? It is the point, location where the entire mass of the body is supposed to concentrate. That point is called what? Center of mass. And if a body is moving under some external forces, and if you apply directly the resultant force at the center of mass, the motion of the body remain unchanged. Okay, so that is the concept of what? Center of mass. Now we will find the position vector of center of mass. Okay, that means how to calculate mathematically the position of center of mass of a body or a system of bodies. That is position vector of center of mass. Position vector of center of mass of two particle system. Of two particles system. So consider a two particle system. Suppose this is x-axis, this is y-axis. So here this is two particle system. Say this mass m1, it's mass m2. Means this system consists of two masses m1 and m2. The position vector of mass m1, so you consider r1. Position vector of mass m2, you consider r2. Okay. Now suppose this is the location of center of mass. This is our center of mass. Now we want to find the position vector of center of mass. Means this one. This we want to find. This suppose RCM. So RCM means what? Position vector of center of mass. So this we have to calculate in terms of m1, m2, r1, r2. Now suppose we apply an external force here, say F1, and here suppose we apply a force that is F2. Okay, that means the system is under external forces F1 and F2. Now you have to find out the position vector of center of mass RCM. Okay, so what we do? So here your net force will be net force on the system, that F is equal to what? F1 plus F2. Okay. Now we know that the total force, if we apply at the center of mass, then motion of the body remain unchanged. That is, the body executes similar types of motion if we apply the total force directly at the center of mass. So this total force we consider we apply at the center of mass because the motion remain unchanged. So this F we can write, use Newton's second law, F is dP by dt, and this equates center of mass. Okay, because we know if total force applies at the center of mass, then motion remain unchanged. So F1 you can write dP1 by dt, F2 you can write dP2 by dt. Now P is momentum, so here d of dt, this you can write m into v, so v center of mass, and this m is what? Total mass. This is m1 plus m2, because we know at the center of mass total mass supposed to concentrate, so this here the total mass is what? That is m1 plus m2. So here capital M is means what? m1 plus m2. Then d of dt, p1 is what? You can write m1 v1 plus d of dt, p2 you can write m2 v2. Okay. Then d of dt, so this m, v I can write dr by dt, so d rcm by dt. So here d of dt m1, v1 you can write dr by dt, so dr1 by dt plus d of dt is simply mathematics. Okay, m2 v2 you can write dr2 by dt. Then this you can write d square by dt square m RCM. Here you can write d square by dt square m1 r1. Just follow the steps, okay? Derivation is not important for us. At the end, you just remember the formula, okay? D square by dt square m2 r2. Or this simply you can write m RCM m1 r1 plus m2 r2. Then this m is nothing but m1 plus m2. As I have told earlier, the total mass of the body is supposed to concentrate at the center of mass. So m is equal to m1 plus m2. So RCM, it will be m1 r1 plus m2 r2. So from here we can find the value of RCM, that is position vector of center of mass, okay? Now here you see RCM will be m1 r1 plus m2 r2 by m1 plus m2. So this is the formula. This formula you have to remember, okay? So derivation is not important. Just to follow the steps how to derive the relations of position vector of center of mass in terms of mass of the two particles and their respective position vector. So we got RCM m1 r1 plus m2 r2 by m1 plus m2, okay? Now this is the position vector of center of mass of a two particle system. We are considering two particles, that is m1 and m2. Now we can extend these relations for a system of n particles, okay? Now for a system of n particles, we can extend this relation. How can we write it? RCM, it will be what? It will be your m1 r1 plus m2 r2 plus m3 r3 up to mn rn divided by m1 plus m2 plus m3 up to mn. Okay, so this is the position vector of center of mass of a system having n particles. Okay, we just extend this one up to n. So these are position vector. Okay, now from here we can derive some relations. Okay, first of all, you see xy coordinate of position vector of center of mass. Position vector of center of mass. Now from this relation you can find out, because r is the what? Position vector. We can write in terms of what? Coordinates. Because you know what is position vector in terms of xy? You know r1 you can write simply x1 I cap plus y1 j cap. Similarly r2 you can write x2 I cap plus y2 j cap. And RCM you can write xCM I cap plus yCM j cap. So here you see, suppose this is the position vector r1 and its coordinate x1 y1, so x1 I cap y1 j cap. And suppose position vector of mass m2 here, suppose its coordinate is x2 y2, so r2 will be what? x2 I cap plus y2 j cap. And this is the center of mass, suppose its coordinate is xCM and yCM, so RCM will be what? xCM I cap plus yCM j cap. This is what two particles suppose. Now here just you apply the relation RCM, you know r1 so RCM, it is m1 r1 plus m2 r2 by m1 plus m2. Now here you just put the values. Part same you can write xcm I cap plus ycm j cap. Then here it is m1 r1 you can write x1 I cap plus y1 j cap. Then m2 r2 is x2 I cap plus y2 j cap. So here m1 plus m2. Then you can write xcm I cap plus ycm j cap. So here it is m1 plus m2. So you can take common I cap. So m1 x1 plus m2 x2 I cap. Then you can write m1 y1 plus m2 y2 j cap. Now if we compare the components, I components, then xcm will be what? m1 x1 plus m2 x2 by m1 plus m2. And not only ycm, it is m1 y1 plus m2 y2 by m1 plus m2. So just by comparing the I and j components from both sides, you can find out xcm and ycm. That is xy coordinate of position vector of center of mass. Okay. Now just comparing, you can write xcm. It will be what? m1 x1 plus m2 x2 by m1 plus m2. Okay. And ycm, it will be what? m1 y1 plus m2 y2 by m1 plus m2. So we got the coordinates, xy coordinate of what? Center of mass. Okay. So you see the x coordinate is m1 x1 plus m2 x2 by m1 plus m2, and y coordinate m1 y1 plus m2 y2 by m1 plus m2. Now this one also you can extend for n particles. Okay, so similar form. Okay, so for a system of n particles, for a system of n particles, your xcm, it will be what? Just to extend up to n particles, m1 x1 plus m2 x2 up to mn xn by m1 plus m2 up to mn. Okay, so this is xcm for n particles. Similarly, you can write ycm. So ycm, it will be what? It will be m1 y1 plus m2 y2 up to mn yn by m1 plus m2 up to mn. So this is the xy coordinate of center of mass. So if we are asked to find the coordinate of center of mass, use these equations. Okay. And if you are asked to find the center of position vector of center of mass in terms of coordinates, then after finding xcm ycm, you write rcm. Okay, it will be what? xcm I cap plus ycm j cap. So just after finding out the coordinates, you can find out the position vector. Okay, by using these relations. Now in this case, if the masses are equal, then what happens? If the masses of the particles are equal, okay, so if we consider m1 equal to m2 is equal to m, then what happens? Then xcm will be what? xcm, if masses are equal, then in case of this m all are equal, so you take m common, so it will be what? x1 plus x2 up to xn divided by what? M plus m up to n times. So this you can write m x1 plus x2 up to xn divided by m into n. So here m cancel out. So it is x1 plus x2 up to xn divided by n. So this is xcm. Okay. if masses are equal, in that case the position coordinate of center of mass is what? Simply x1 plus x2 up to xn by n. Similarly, you can find YCM. It will be what? It will be y1 plus y2 up to yn divided by n. So this way you can find out the coordinate of center of mass if masses are equal. If masses are equal, then simply x1 plus x2 up to xn by n, and YCM will be what? y1 plus y2 yn divided by n. So this way you can find out the coordinate of center of mass. Okay. Okay, then another point, if the center of mass lies at the origin of the coordinate system. Okay. So if the center of mass lies at the origin of coordinate system, so suppose here, this is suppose a coordinate system, here suppose m1 and this suppose m2. This is x1, this suppose x2, and here this is center of mass. So here center of mass lies at the origin. So what happened? Your xcm will be what? 0, because it lies at the origin. So xcm will be 0. Now here you write the formula m1 x1 plus m2 x2. Here we can write minus x2. Why I have taken minus x2? It is negative x-axis. Okay, by m1 plus m2 equal to 0, or simply you can write m1 x1 it will be minus m2 x2 equal to 0, or it will be m1 x1 is equal to m2 x2. So this is one of the important relation. Okay, m1 x1 equal to m2 x2. So this relation, okay, this relation will use in finding the position of center of mass of a two particle system. So whenever in questions it is asked to find the location of center of mass, okay, for a two particle system, always use these relations. We'll see the numericals, it will be clear. So always use these relations m1 x1 equal to m2 x2 to find out the location of center of mass of a two particle system. Okay, remember this. These are one of the important relations. Okay. Now let me give you one question. Suppose in HCl molecule, the mass of chlorine atom is 35 times the mass of hydrogen atom. Okay, and separation between them is say 1.5 Armstrong. Find the location of center of mass from hydrogen atom. Okay. So in HCl molecule, the mass of chlorine atom is 35 times the mass of hydrogen atom, and separation between them is 1.5 Armstrong. Find the location of center of mass from hydrogen atom. So here you see, this is suppose HCl molecule, this hydrogen and this chlorine. Separation between them is given 1.5 Armstrong. You have to find the location of center of mass from hydrogen atom. Suppose this is the center of mass, say this is center of mass. So this suppose x1, this is x2. So here you see it is a two particle system. So you consider the relation that I have explained, m1 x1 equal to m2 x2. So here suppose mass of hydrogen suppose m1 and for chlorine suppose m2. So use this relation here, m1 x1 equal to m2 x2. So m1 x1, m2 will be what? It is given mass of chlorine atom is what? 35 times the mass of hydrogen atom. So here m2 you can write 35 m1. On x2 you can write what? 1.5 minus x1. So x2 you can write 1.5 minus x1. So m1 you can cancel out. So here x1 equal to 35 into 1.5 minus 35 x1, or 36 x1. It will be what? 15 into 5, 75. 45 plus 7, 52.5. So x1 it will be 52.5 by 36. So just divide it, you can find the value. So this way you can find out the location of center of mass of a two particle system. So whenever these types of questions asked, you always use this relation to find the location of what? Center of mass. Okay, m1 x1 equal to m2 x2. Okay, take another question. Now suppose you are given a plane lamina here, a plane lamina xy. Suppose it consists of three squares. Okay, this is a square, this is a square, and this is a square. Each square has length, suppose 1 meter. Is 1 meter. Okay, 1 meter. 1 meter. And mass of each square is 2 kg. Suppose that is mass of each square is 2 kg. Is 2 kg. Its mass also 2 kg. Its mass also 2 kg. Now you are asked to find the position of center of mass of these three, with entire 3 squares. You have to find out position of center of mass, or you can say coordinates of center of mass. You have to find out. Okay. Now what you have to do, you have to find the coordinate center of mass of each square. Then you can find out the overall. Now for this square, you see this is a code. This what are the coordinates here? It is 0 0. It is 0 0. Each coordinates is what? It is 0 2. It is what? 2 0. Okay. Now here you see this is the center of mass of this square. This suppose C1. This is center of mass of this square. This one. This is suppose C2, and this center of mass of this square. This suppose C3. So first you find out the coordinate of center of mass of each square separately. Okay. So what will be the coordinate of C1 here? This coordinate, it is at the center. So this one you see, this one. So the coordinate is half, because here to here 1 meter, so it is half. So half and half. Okay. What is the coordinate of C2 here? C2, this one. So here it is half, but here it is 1 plus half. That is half and 3 by 2. Then what is C3 here? C3, this coordinate, C2 this one. C2 is what? What is C2 here? X coordinate you see. Here to here 1, then it is half. It is 3 by 2 and half. And what is C3? This one, C3. So it will be what? Half and 3 by 2. So we got the center of mass of each squares. Now you can find out the overall center of mass. So here you see masses are equal. So to find out XCM, we use simply this relation. X1 plus X2 plus X3 by 3, as I have discussed earlier. Okay. X1 here half, X2 here 3 by 2, and X3 here half by 3. So it will be what? 5 by 2 by 3. It is 5 by 6. Similarly, you find YCM. Okay. YCM is what? Y1 plus Y2 plus Y3 by 3. So Y1 here half, Y2 half, Y3 3 by 2 by 3 is also 5 by 6. So we got the coordinates of what? Center of mass, XCM and YCM. So here XCM and YCM, it will be what? It will be 5 by 6 comma 5 by 6 meter. So this way you can find out the position, there is coordinates of what? Centromeres. Okay, thank you.